Hey everyone, welcome to your first video lesson. By the end of this video, you will be able to simplify radicals and successfully complete your homework. Simplifying radicals doesn't seem very simple at first, but once you get the hang of it, I promise you, you will have lots of fun. When I use the term radical, what I mean is the square root symbol. So the radical with the number 36 underneath is what we know as the square root of 36. We all know that to be positive or negative 6. We call 36 a perfect square because its answer is a whole number. Its answer is a rational number. Remember from earlier in the week when my side lengths are 6, what I would find the area of that square to be is 36. I have found my side length times my side length, which happen to be the same number, equals 36. So 6 squared is 36. In reverse, I would say the square root of 36 is 6. They are opposite operations of each other. Off to the side, I have our reminder of the square root of 36 being 6, which will help us do this problem, the square root of 72. The square root of 72 is going to give me an irrational number, so now I have to simplify this radical. 72, or the square root of 72, is another way of saying the square root of 36 times 2. Because isn't it true that 36 times 2 is 72? So now I take this and I can simplify it even further by breaking it apart as the square root of 36 multiplied by the square root of 2. Now I know that the square root of 36 is 6, so I can simplify this one more step. This becomes 6 times the square root of 2, and we will write that as 6 radical 2. To give me the answer of 6 times the square root of 2 being the simplified radical of the square root of 72. I have simplified the square root of 72 as 6 times the square root of 2, and there's my answer. Let's now try the square root of 50. The square root of 50 can also be written as the square root of 25 times 2. Remember, this is another way to write the square root of 25 times 2 as the square root of 25 times the square root of 2. Hey, I know that the square root of 25 is 5. 5 times the square root of 2, simplified, or just written a little simpler, is 5 times the square root of 2. I have simplified the square root of 50. This radical simplifies to 5 times the square root of 2. There's my answer. But you're probably wondering why I didn't try other options. I know the square root of 50 is also equal to the square root of 5 times 10. Or I guess it would also be equal to the square root of 1 times 50. I didn't choose these because there's nothing more I could have done. 5, 10, 1, and 50 are not perfect squares. Those would give me an irrational answer. So what I did was list out the factors of 50, 1 and 50, 2 and 25, 5 and 10, and I saw that of these factors, the greatest factor that is a perfect square is 25. In this case, the only factor that is a perfect square is 25, but if there were other factors that were perfect squares, I would choose the greatest. This is why I chose the two numbers to break 50 into, 2 and 25, so I could have taken that perfect square and turned it into 5. Let's try now when I have a number in front of my radical. For example, 7 times 45. Let's actually list out those factors to help us see the perfect squares. So listing out the factors of 45, I have 1 and 45. I have 3 and 15. I have 5 and 9. I'm going to go through and circle all of my perfect squares, and it looks like I have just one perfect square, which is 9. So that's what I'm going to use. So I'm going to rewrite this as 7, or the 7 times the square root of 9 times 5, because 9 times 5 gives me 45. So this is really 7 times the square root of 9 times the square root of 5. I can simplify this as 3. So 7 times 3 times the square root of 5. If I write this a little simpler, I have 21, which comes from 7 times 3 times the square root of 5. Voila! Here was my original radical, and simplifying that radical is 21 times the square root of 5. To walk you through what just happened, again, I've listed out my my factors. I found the greatest perfect square and chose this pair, these factors of 45 to go under my radical. Then I broke it apart into 7 times square root of 9 times square root of 5. The square root of 9 is 3, so I simplified then the 7 times 3 to get 21. Multiplied it by square root of 5 to get my square root of 5. And I cannot simplify that anymore because the square root of 5 would be irrational. Let's try one more example before we get going on our homework. We have 4 times the square root of 20. 4 times the square root of 20 is not simplified because 20 is not a perfect square. Oh, wait a second. I guess it wouldn't have to be, but I can simplify 20 from what's underneath that. So I have my factors of 20 as 1 and 20, 2 and 10, 4 and 5. And now I'm going to go through and circle all of my perfect squares. 4 is my only perfect square. It is the greatest of the one of them, so I'm going to use that. And this is now going to be the factors that I put under the radical. So I have 4 times the square root of 4 times 5. And breaking it down, it becomes 4 times square root of 4 times square root of 5. I can simplify the square root of 4 as 2. I now have 4 times 2 times square root of 5. 4 times 2 is 8 times the square root of 5. So what I have in front of my radical is being multiplied by what I can simplify out of that radical. 4 times the square root of 20 simplifies to 8 times the square root of 5. If you are understanding this, go ahead and start your homework. If you are not understanding this or would just like to see some extra practice, let's do a couple homework examples together. For those who are starting their homework, good luck. And for those who are trying homework examples, let's flip out our homework to problem L. We will start with problem L. L is the very first problem, first row, top left corner, and the directions actually tell me to, in each of those quadrants, find or simplify the radical of L, I, A, T, O, S, E, all of those letters off to the left. Simplify those radicals, find their answer to the right, and then the answer, or the number to the answer that goes with the letter to the radical is what you write down below. And it's broken into 4 quadrants, so do one quadrant at a time, as those answers in the second column belong to the questions in the first column. So starting with L, the square root of 8. I'm going to list out my factors of 8, 1 and 8, 2 and 4, and that's it. Circle my perfect square numbers, and 4 is it. So I'm going to simplify square root of 8 as the square root of 2 times 4, which is the square root of 2 times the square root of 4. The square root of 4 is 2, so I end up with 2 times the square root of 2. I can look over to my right column and I see that that value, 2 square root 2, is 12. So I'm going to look down below of my homework, find the number 12, and underneath the letter 12, I'm going to write the letter L. Let's do one more problem from your homework, and let's look at the top right quadrant with the letters S-U-A-P-E-K-L. Let's do problem K. Problem K is 8 times the square root of 27. So the first thing I'm going to do is list out my factors of 27, and that's 1 and 27, 3 and 9, and that's it. My perfect squares, I only have one, which is 9. So I'm going to rewrite this as 8 times the square root of 3 times 9. Another way of writing that is 8 times the square root of 3 times the square root of 9. Looking at the square root of 3, I can't find that. It becomes irrational, but looking at the square root of 9, I can simplify that to 3. Okay, so now I'm going to multiply my two numbers, 8 times 3, which gives me 24, and I leave the square root of 3. So my answer is 24 times the square root of 3. When I look over to the right, the number that signifies the answer to this question is 13. So down below I'm going to look at number 13, and underneath number 13 I am going to write K. When you are done with your homework, go on to Moodle and you will see the answer key so that you can check your homework, verify that what you are doing is correct. If it is not, if you're having troubles with simplifying these radicals or some of these radicals, please see me right away in the morning. Since we don't have math together tomorrow, I would like you to stop by in the morning so I can simplify. So I can answer your questions on simplifying radicals. Before you leave, I have one joke of the day, because you always need a joke of the day when you are done with a math lesson. I got this joke from a student a couple years ago, and when she first said it to me, I was absolutely disgusted because I didn't know what it meant. But when you think about it, it's actually kind of funny. The joke is, what is brown and sticky? Your answer is a stick. See you tomorrow. Bye.
Made with Doodlecast Pro.